Transformation of functions. A quadratic function has the equation f of x equals to x minus 4 times x plus 3. Determine the x-intercepts for each function. We have a video in which we have discussed almost the same thing. Now, I would like you to answer this question and then look into my suggestion. Now here we have three functions. The functions are y equals to minus 2 times f of x, y equals to f of minus 2x, and y equals to f of x minus 1. So you need to tell me the x-intercepts on this function. When we transform the function, then where will they be? So their new location or the image points of the x-intercepts. Now to answer this question, let's first find original x-intercepts. So the x-intercepts for us are at x equals to 4 and x equals to minus 3. Let me write down them as minus 3, 0 and 4, 0, right? So these are the two x-intercepts. Now let me show you with the help of a diagram. So when we transform the function, then how does it look like? So this is a function which is opening upwards, quadratic parabola with two x-intercepts, one at minus 3, the other one at 4. So we can draw a parabola kind of like this. Approximately, this may reflect the situation. And this point is minus 3 for us, and this is 4 for us. Now one by one, let's look into the transformation. The first one is minus 2 f of x. Now if I have this kind of a transformation, then how will the points get transformed? If the original point was at x and y, then this transformed point will be, here as you can see, there is transformation on the y point. So here it will be x and minus 2y. That is how the points are going to get transformed. Now, how will our x-intercepts get transformed? This is what we need to figure out. Now in this case, x-intercepts have y value of 0. So if I multiply anything by 0, it doesn't change. It remains 0. And x value has to be same, right? So in this particular case, our x-intercepts will be at the original position. Do you see that? It will be like minus 3, 0 and 4, 0. They will remain unchanged. Since there is no horizontal translation or compression, x-intercepts will not change, right? With vertical stretch or reflection, what will happen? This point is going to remain there. The graph may flip, it may stretch, but at 0, 0 times anything is 0, so it remains same. So that is kind of an interesting thing to take. Now the next one is minus 2x. So how are the points getting transformed here? The original point, let us say, is xy. So in this case, x points get multiplied by minus half. So we get minus half x and y, right? So the new points will be minus of minus 3 will be plus. So we'll have 3 over 2, 0 as the first x-intercept, and the next one will be minus of this. So that is minus half times 4, which is minus 2, 0. So that is going to be the location of our x-intercepts when the function is f of minus 2x. I hope you appreciate that in this particular solution, I am giving you a different approach than what I have given you in the previous one, so that you can understand both possible approaches and adopt the one which you like most. Now here, how are the points getting transformed? The point, let's say xy, is on the function f of x. Then on this transformed function, x point is moving 1 unit to the right, and there is no transformation on y. So the original point xy will be image to x plus 1 y. Therefore, the x-intercept's new location is going to be minus 3 plus 1, which is minus 2, 0, and 4 plus 1, which is 5 and 0. So these are the new locations of my x-intercepts for the three transform functions given to us. I hope you appreciate how we did this kind of question in the two videos. Here the approach has been to do transformation of points and understand how a point on the image get transformed using this, right? And in the previous one, we did transformation as we sketch it, right? It was more a graphical solution. So that is how we can actually solve these kinds of problems. I hope that helps you. Thank you.